Alright guys, today we're going to start a new unit, and this unit actually jumps off of some things that we've been talking about before, in that we're still graphing some lines, some linear equations, and trying to find solutions for them. But this is going to be a little different in that we're going to graph or work with two equations, alright? And that's why this is called systems of equations. Whenever you see the word systems of equations, that means you're dealing with more than one equation. Alright? So this first exercise here, we have a situation that they set up, and it is about a family that has two plans to choose from. Notice it has two different plans, so that's going to tell me I'm probably going to need two equations to describe this situation here. Alright, now I want you to keep in mind, I'm going to write up on the top here y equals mx plus b, because we're still dealing with linear equations, meaning lines, and so all of these equations that we come up with are still going to take this form. Alright, so we're still dealing with slopes, and we're still dealing with y-intercepts and such. Notice that I have my graph over here, and I've already pre-labeled it because I kind of looked ahead a little bit and I didn't want to waste time on the video to do that. So if you need to pause the video in order to copy down, what we're going to use as a scale, I went every other block as $10 over here. Alright, this is my cost, and I can say this is cost. Usually you put a unit over here for cost, and that's going to be money. And along the bottom is going to be months, and I'm just going to go by one, so I don't really need to label that over here. Alright, so let's try to create equations that describe these situations here. We have plan A, and this is kind of usually the toughest part for some people to do, is to take the words and convert them to an equation. Alright, so let's walk through this first one. You pay $20. Well, that's pretty easy. Let's go over here, and in blue I'll make the equation for plan A here. I'm going to pay $20. Alright, so I'm going to put $20 down for the modem. Alright, and this is for cable service here. So usually when you have cable service nowadays, you have to pay for a modem, and then you're going to pay $3 per month. And I try to give people hints. We've done this before, where you see that per month. That is usually a good indicator that you're going to multiply by some variable. Alright, and if you read down the rest of this, we're looking for the total cost of what your cable is going to cost over the long run here. So what we don't know, or what our unknown is that months. How many months are we going to pay for? Alright, so I'm going to start right up here, and I'm going to say let x equal the number of months. Alright, that's what I'm after, or that's the thing I don't know. So we're going to pay $20 for the modem. Alright, so I'm just reading it right along in the sentence here. $20 for the modem, so I put down a 20. And then we're going to pay $3 per month. So that would be an additional cost, so I'm going to add in $3 per month. Well, that's going to be $3 for every one of these x's that I have. Alright, so there's what I'm going to pay, and that's going to equal, put a little equal sign here, that's going to be how much I pay in total. So I'm going to use a C for my cost. Alright, so x is the number of months, and C, if I want to write that down over here, C equals our cost. Alright, so those are our two variables. Alright, now this is somewhat different because we have two things that we don't know. Not really though, because over here in y equals mx plus b, we have y and x that we don't know. But what's going to be different is we're going to now make another equation for plan B. Alright, so let's write down plan B. And again, I'm just going to go right along in the sentence. And the modem is free. Well, that's good. No, we don't have to add in that $20. So the modem is free, and you pay $5 per month. See that per month again? Alright, so I'm going to put 5 for every one of the x's, this same variable up here, number of month, and that's going to equal my cost. Alright, so notice, I want you to notice this, is that these are still in the form y equals mx plus b. It's just written backwards. This would be y equals mx, right? Mx, so there's my slope. My slope in this one is 3 plus a b. So my y-intercept is 20. Okay, this one could also be in y equals mx plus b. So we have y equals mx, right there, 5x, and plus b, well, the b just happens to be a 0 in this case. So we don't have any plus b. Our y-intercept would be 0. Alright, so let's go ahead and try to graph these, and we'll do the first one in blue because it's blue over here. So my y-intercept, remember what we did before, you go to your y-intercept first. Your y-intercept, I'll put that right here, y-intercept is 0, 20. So I go there first and I put a dot at 20. Alright, and then I'm going to use my slope. My slope is a 3 over 1. Alright, now the way I have this labeled here, every block is 5, so this is not going to come out nice and even. The other one will, that's why I did it this way. Alright, but I'm going to go up 3 over 1. So that's going to be an approximation right there. I'm going to say 3 is about there. And I'm going to go up 3 more and over 1. Okay, and again, that's going to be just above that because now I've gone a total of up 6 over 1, right? And I'm going to go up 3 more, right? And that's going to be right below that one over 1. Okay, and I'm starting to build, see, I'm starting to build a bunch of points there. Alright, and I'm going to take my ruler and I'm going to connect all those points. Alright guys, so I took a minute and I graphed a couple of other points that I knew worked for this, and you can see I went ahead and drew my blue line in there. That represents plan A, so I'm going to go ahead and label, since now we're going to have 2 lines on here, I'm going to label this one 20 plus 3x equals c. That's really important that you guys do that, okay? So go ahead and label that line. This needs to be really straight though. I did my best. You know, I don't have a ruler on this thing because here's what we're going to do. We're going to now graph this other line, and the y-intercept here. The y-intercept here is 0, 0. You see this y equals mx plus b. Well, this plus b doesn't exist, so that's the point 0, 0. That's pretty easy. And the slope for this one is 5 over 1. Alright, and the nice thing about doing this line is it's going to go right on where we have coordinates that come together here on our coordinate axes here, because I'm going by 5s. Alright, so I'm going to go up 5 over 1, up 5 over 1, and I'm going to keep going so that I get a whole bunch of points here, because what I'm looking for is the solution to this system. Alright, and they've got to be spot on. You can see this one's really close, that one's really close, but that blue line, if you do it with a ruler, does not go through that point there, but this one right there, see, that's where they cross. Okay, and these ones are not crossing, and all of a sudden it gets higher right here. This red line gets higher. Okay, so I'm going to go ahead and put the rest of these in, and then I'm going to connect them with a line, and hopefully it's going to be nice and straight so that you can see that these don't cross, but that one does right there, but these don't cross. Okay, and of course with a ruler it's going to be spot on for you. Alright, and I'm going to go ahead and label this one, what is that, 5x equals c. Okay, so the person reading the problem knows that this line, this red line, is the 5x plus c, or 5x equals c, and the blue line is 20 plus 3x equals c. Alright, so what we've done is we've created 2 lines, 2 graphs, and we want to see when they would cost the same amount. It says graph the 2 equations to see when the 2 plans would cost the same amount. So right here, okay, and I'm going to circle this one, Alright, here, that's the point where they cost the same amount. Alright, and that is the point if I go straight down here. If I go straight down, that is equal to 10 months. Alright, and if I go straight across, that is equal to $50. Alright, so after 10 months, alright, to answer our questions, the plans cost the same after, or at, I should say after, because it is really at 10 months. Okay, we'll change that to at 10 months. Okay, so you can see where I'm looking where they cross. And this other part here, down here, says, when is Plan A the better deal? Well, Plan A is the better deal. Plan A is the blue line over here. Plan A is the better deal when its line now is less than the red line. Okay, so in the first 10 months, you're actually paying more for Plan A, but then once you hit that 10-month mark, it starts to cost you less than Plan B. All right, so we're going to say after the 10th month, okay, Plan A starts to be a better deal. So sometimes you have to look in the future and say, oh, it's going to cost me, less up front for Plan B, but then after 10 months, if I plan on having this more than 10 months, then it'd be better for me in the long run to go with Plan A. All right, so there's question number 1. You can see the kind of thing we're going to be doing here. The next few exercises are similar. So let me get this cleared off, and we'll go on to exercise 2. Alright guys, this is number 2, and you're going to find this one is very similar, but we've got some different units that we're dealing with. Alright, I'm going to put y equals mx plus b up here again, because I know that these equations are going to take this form. Alright, so it says Ben and his brother Nick are going to have a race. Nick is older than Ben, so he is going to give Ben a head start. So Ben gets a 10-foot head start and is running at a constant rate of 7 feet per second. So let's just take this part and try to create an equation about what's going on here. So we know that he's going to get a 10-foot head start. So let's do Ben's equation right here, and he's going to be ahead of Nick for 10 feet when they start, and he's running, right? He's running, so we're going to add a constant rate of 7 feet per second, and here is that per second again, just like in the last one. It was per month, so I'm going to have 7 feet for every second, and that's what I don't know. I don't know how much time they're going to run, so that's going to be my variable. I'm going to say let x equal the time in seconds. Okay, I could use a t if I wanted, but I'm going to use an x. And then we'll use, say, a d, alright, for the total distance. And you can see, again, I took a little time ahead of time and I labeled my axes over here. So if you want to pause the video and do the same, that's fine. But we're going to jump right in and finish this equation. He did 10 foot head start, and then he's running at 7 feet per second. Well, that's going to equal his total distance. I'm going to put the d over there this time. So now, are we in the form y equals mx plus b? Well, sort of. If we really wanted to, we could switch this 7x and this 10 around. We really don't need to. But it really is y equals mx, that would be your 7x, plus a b, that would be your 10. Alright, so far we have a y-intercept. Okay, we have a y-intercept of 0, 10, and we have a slope of 7 over 1. So we can go ahead and graph that. That's pretty easy to do here. We're going to start right here at 10 for his head start, and he's going to go up 7 over 1. And again, these are going by every block is 5, so they're not going to come out right on where two coordinates come together here. I'm going to go up 7 over 1. And if I go up 7 again, and over 1. I'm going to be right underneath that line there. And I'm going to go up 7 over 1 again. So that would actually be right above that line. I'm going to go ahead and fill in the rest of these. And you do the same. And we'll see if we come up with the same thing. Now I graph 0, 10, that's my y-intercept, and now I'm going to graph up 7 over 1. Notice along the bottom I went every other block was 1 because I know I didn't want to squeeze my graph into a really small space here. Alright, so I'm going to go up 7 over 1, which is actually 2 blocks, and I'm going to put a dot. So I put one right here, and I do the same thing, up 7 more over 1, and I put a dot, and up 7 more over 1. So I'm going to go ahead and I'm going to finish my line. You guys can pause the video and do the same thing, and you'll see what we get. Okay, so I went ahead and I graphed some points here that I know work. I plugged in a 5 actually, and that came out nice and even right on 45, and I plugged in a 10. I wanted to get one way out here, and that came out right on 70, and then I connected the dots. So now let's do the other equation here. The other equation, Nick starts running at a constant rate of 9 feet per second, and he doesn't get a head start. So Nick's equation is just going to have a slope, or that 9 feet per second, but it doesn't have a y-intercept, or it has a y-intercept of 0, really. Okay, so his equation, Nick's equation, is just going to be d equals 9x. Alright, so that 9 feet per second. Alright, so the y-intercept here is just simply 0, 0. Okay, and the slope is going to be 9 over 1. Alright, I don't really need those parentheses there. Okay, take that out. Slope equals 9 over 1. Alright, so let's go ahead and graph that. And the y-intercept, we always start the y-intercept, that's 0, 0. And I'm going to go up 9 over 1. That's going to be about there. And I'm going to do the same thing, guys. I'm going to pause this, and I'm going to then do the rest of the line, and you can do the same thing, and we'll compare. Alright, so you can see that I graphed a bunch of points, and I found the place where they intersect. They intersect right at that coordinate right there. That would be 5 seconds in, if I go straight down here, and their distance is going to be 45 feet away. So it says, graph the two equations to see when it is that they have run the same distance. So to answer my question, it is 5 seconds. They're asking when, so 5 seconds is when they have run the same distance. Alright, they have run the same distance. Okay, so I make sure I answer my question here. Now they do say if they run a total of 100 feet, okay, if they run a total of 100 feet, who is the winner? Now on my graph, my graph doesn't go out until they reach 100 feet, but it's very easy to see that at this point, right, up to this point, Ben is winning, but right at that point, Nick is going faster, and he overtakes him and is now winning after this point, and that trend is just going to continue. So at 100 feet, Nick is going to be the winner. If it was only 45 feet long, they would tie, right? And if it was anything less than 45 feet that they were running, Ben would be the winner there. Okay? So, but they went 100 feet, so that is Nick is the winner there. All right? So there's number 2. Let's go on. There's one more. Let's go on to number 3 here once I get everything cleared off, and that'll be it. Alright guys, here's exercise 3, and again I've gone ahead and I've labeled the graph. Kind of looked ahead and to see what I'm going to need. I went by every block is equal to 20, and this is going to be distance over here. So if you want to pause the video and copy that down just so it is all set for you when we go to graph it, go ahead. And so we're going to start by building some equations here. Again, it says Warren and Carrie are driving across the state. Carrie drives faster than Warren, and she drives at 70 miles per hour, while Warren drives at 45 miles per hour. So they knew this. And actually, you know what? We're going to change one of these because I know that I want it to work out nice for you. Okay, so I know that I'm going to change this 45. We're going to make that a 40. Okay, so on your paper, if it's not changed already, it may be changed already, but I'm going to change that to a 40 if it isn't. So let me go back to my color here. All right, so let's try to describe this. It says Warren knew that he tends to drive slower, so he left at 8 a.m. Carrie left at 11 a.m. All right, and they're trying to get to the same place. So let's describe some equations here. And what I don't know is time. All right, I don't know how many hours they're going to drive to get to where they need to go. So I'm going to say let x equal the time. All right, the time in hours. Now this one's a little different because they're leaving at different times. So you have to decide, like, what is going to be time 0 here. Okay, so let's start by describing, let's go with Carrie's driving. All right, and Carrie left at 11. So let's say Carrie here, Carrie's distance, all right, D is going to be distance. We can put that over there. All right, D is going to be distance, and they're driving. She is going. See that 70 miles per hour? See that per hour again, guys? Just like in the other ones, that's going to be 70 for every hour. So that's going to be 70x. All right. Now Warren, we're going to put Warren's down here. We'll put that one in red. Okay, Warren drives, and he goes a certain distance, but he is going 40 miles per hour. Okay, so that's 40 for every x, and he left 3 hours in front of, all right, 3 hours ahead of Carrie. So that is 3 hours, and let's see, he's going 40 miles an hour. 40 miles times 3, that's going to be 120. Okay, so let's see what we get into here when we graph these. All right, so let's do this equation in blue first. All right, let's go the y-intercept here. That is going to be, let's see, y equals mx plus b. That's going to be 0. So that's the point 0, 0. And my slope, right? My slope is what? My slope is 70 over 1. That's mx right there. So let's go over here and we'll graph 0, 0. I always start my y-intercept, and I go up 70. All right, now these are going by 20, so 70, actually this is going to be 2, 4, 6, 70 is going to be right in between these two blocks, since this one's going to be 60. So I'll go up 70 and over 1, and that is going to be right there, okay? And then I go up 70 again. Well, 70 and 70 is 140, so that would actually be up to this block right here and over 1. That's going to be right there, okay? And up 70 again, that's going to be 210. All right, so that's going to be in between these two and over 1. And then up 70 again, that's going to put me at what, 280? Yep, and over 1. That's going to be right there. So you can see what my graph is going to look like for Carrie's driving time. So I'm going to pause this. I'm going to put in the graph here, so hold on just a minute. Okay, so you can see I put in the blue line, which is going to be Carrie's driving distance. Let's label that one. We could just go right up here and put D equals 70x and put a little arrow. That makes that labeled. Alright, and now let's do Warren's driving distance. The y-intercept here is y equals mx plus b. There's my b, so that's 0, 120. So he gets 120 miles head start. Alright, basically is what we're saying here. So m, or my slope, is going to be 40 over 1. Okay, so we go over here, and 0, 120. Oh, there should be a plus there, shouldn't there? 0, 120 is going to be right here. So you can see at the beginning, right? This is at what time? This is at 11 a.m. 11 a.m. Warren is actually 120 miles into the trip here. Okay, so, and he's going to go 40 miles an hour. He's going to go 40, and each one of these blocks is 20, so I'm going to go up 40, and I'm going to go over to 1, and there's his next one, and I'm going to go up 40 again, and over to 2 hours, and up 40 again, and over there, and up 40, and you can see these are going to come together right at that 4-hour mark. Okay, and then all of a sudden he falls behind. Okay, so up 40, I'm going to do one more here. That's 1. And I'm going to try to connect the lines here. Hopefully this goes well. And bam. There we go, right through there. Not the best line in the world, but I can see, I'll switch over here, I can see right here is where they are going to catch up with each other, or one person's going to catch up with the other person. Alright, so go ahead and label this line as well. This is D equals 40 x plus 120, and we put a little arrow to that one, so we're labeled. And so when or if or when is Carrie going to catch up with Warren? Well, if I go right where they intersect and go straight down, well, that is going to be 4 hours. Okay, so 4 hours after, and make sure you get this right, after 11 a.m. Okay, because this is, we're looking at after 11 a.m. here. The graph would be a little different. It would still come out to well, it would come out to later, but it would be a little different if we said time 0 here was going to be 8 a.m. Alright, our equations would be a little different. Alright, so time 0 is 11 a.m. Okay, so there's the answer. Hopefully we got the gist of this, writing these equations, but basically the difference, we're writing 2 equations now, and we're graphing them, and we want to come up with where they cross and other things to answer some different questions that go along with these 2 lines here. Alright, so thanks for watching. We'll see you tomorrow. Have a good night.